Okay, for the first criteria, and it'll be on the test, you'll see it, and I know you know it already. Yeah, that's right here, right here. No. Get a desk. Okay, paper, pencil. This is your first question. Okay, I want you to know that there are three ways to prove, or three ways to prove that, and we're going to use it as proof, but we can prove it individually. Prove that triangles the triangles, three ways to prove that triangles are congruent. And one of them, you know, you already used it in your proof before. Oh, that reminds me, I'm trying to post all your grades into Google Classroom. I think I have most of them, but there's some who are not enrolled in the class. I can't enter your grade. If you don't have the code to get into class, let me know. I'll give it to you. Okay, so three ways. This is one way. This is number one. Okay? It simply says that if you got two triangles, you look at the hash mark, you got one there, one. You can see the three sides are equal. I think it's almost intuitive that the corresponding angles are equal. Right. Second one, second criteria. This is the second criteria to prove that two triangles are congruent. It's a different one. It's side angle side. Let's see if you can see that. So it's saying what that means is that I got a side, and then in the middle I have an angle, and then the side I got a side. You see, side angle side. Now, if this angle, see if this is intuitive to you. But if you got an angle here, right, and this distance is this distance is the same as the next triangle, that one. But that angle, see, this one's side angle side. This is side angle side. That means that side, you know, is congruent with that, and this side's congruent with that. You see? So I wonder if you can see if you know this angle where my head is, and you know the lengths of these two. I'm sure you see if they're connected. It'll be the same as what we call a congruent angle. Okay, the next one. So this is number two.
Did you draw that triangle?
Okay. Well, it's right here, but so I can make it bigger if you want. Okay. All right. So the first case of congruent triangles. The first case was side, side, side. Now all three. You got two triangles, right? Or these two. And then we have the other one. This is going to be what we're talking about right now. Side, angle, side. So I'm saying if I have a triangle like this, and I got a perfect copy of it, something like this. Not a perfect copy, but let's say they are. Then if I know this angle, we know it. If it's given to us, we know that x is some number. And that's the same as this is x. And if this side is congruent to this side, and this side is congruent, then we don't have to say anymore, but that these two triangles are congruent. Huh? No, that's side, angle, side. So let's try it again. Okay, let me start from, Okay, so if you have two identical triangles, so if you have two identical triangles, okay, so I'm just going to make two identical. There, and I'll do another one. Okay, we've already many times gone over it. I mean, it's pretty clear if they're identical that this is going to be the case, right? That congruent with that, and that, and that. This shows that these two triangles are congruent. So I'll put this symbol means congruency. Okay, the next one is saying if I have two triangles, they're identical copies, right? And I know that this side is congruent to this side and this side, but I have the included angle. This one, you see, that is, so this is what we know, that this side and this angle is the same, and then this is congruent. You see, that's a side, that's an angle, and that's a side. So if you have two, what we can assume are going to be congruent, we test it. How do I know that? Well, I know this distance. I know the angle. I know this distance. So if I know that same on another triangle, this one, then this has to be necessarily congruent. Do you agree? Because everything else is a perfect copy. So this distance must be all right. So by the side, angle side, see this one's by the side. So what do we got? We got side here, the same as that, and we got the angle, same as that. We have a side. So that's the other criterion. It's another criteria to just show that two triangles are congruent. Make sense? Okay, criteria. I actually out that disappears. Okay, does everybody have a drawing? Okay. I don't know where. Over there. Very opened up right there. God, it's a big. Oh, there it goes. It's a big. Okay. So like side, angle, side, that's another way of showing what? That these two triangles are congruent. Okay, so just cleaning that up. Let me move it up. I'll go over it again. But first, I want to go up to the next page. Okay, it's angle, side angle. Angle, side angle. What about angle, side angle? Well, again, let's see. Let's go through it. So now I have. Okay, so let's just step through it again. From the very beginning, it says two triangles are congruent. If the corresponding sides are congruent. I make it easy because they could turn it and spin it, but it's still okay. And this is by the rule of side by side. That's the first one. The other one we had side angle side. So I'm saying that this side and this angle, okay, and I got this side. So that is side angle side. And if I have an identical one, copy of it. We're trying to show it's identical. And I say, oh, sorry, this is two ticks. So this is one tick, two hashes, two ticks, right? And then I'm saying, like this is the thing. You see it? Okay, and this is congruent. And the rule for this, side, angle. The rule is side, angle, side. And now we have another one. It's angle, side angle. So suppose I have a triangle like this. Okay, so I have a triangle like this. and I have what I'm trying to show is congruent. Okay, so if I have, on this one, if I have this angle, if it makes sense to you, if I have this angle, and it's congruent to this angle, and then I have this side, and that's congruent to that side, then I have this angle, and congruent to this angle, then you've also showed that these two triangles are congruent. Does it make sense? If you had two angles like this in a base, they're going to meet at the same spot. Okay. So, and this one is going to be by angle, side angle. Okay. So up to now, with the proof, when we showed the interior of a triangle is 180, we used this. Yeah. What do you think you draw? Oh, sure. Yeah, you take pictures. Good stuff. Okay. I'm trying to record it as well, so I'll try to post it. Experimental. It's in okay. So what is there another case? Well, let's see. Oh, we have another case. And now we have angle, side. That one's kind of weird. I don't know if you can see this triangle here, but what they're saying is that you have angle, that angle is the same as that angle is that angle, and you have one side. Now be careful, this has to be side, well, that's what it is, a side, angle. Okay? So this one's side, angle, side. So I'm going to go like this. Now, what I'm talking about is yet another rule to show that this is two congruent triangles. I'm just straightening them out so you can compare them, but I'm going to go like this. Okay, so if we have this, and this, and I want to see, and I have the angle, well, let me put that in. I have the angle, yeah, and I'm saying that's congruent to that angle, right? And then I have another angle, right? And then I have a side. So let's do like this. And by the way, this is like this too. So do you see? I only thing I know is this distance, one side. Then I have angle. What's that? A little what? Over here? Maybe not. Oh, that's double. Okay, so when I do an arrow, I mean like a triangle, and I want to compare the angles, I've been doing this. That's good that you asked. I'm saying this angle is congruent to this angle. And I'm saying this is just to differentiate. You see I have two lines? I'm differentiating, saying that that's congruent to that. And of course, my third angle, I would do probably the same thing. Here's the question. What if I give you angle? Is it congruent? You have two triangles that have exactly the same angles. Are they necessarily congruent? Who said yes? You did? Okay, let's see. So if I have a triangle like this, all right, and I make another one that's exactly the same angle, could it be this? Could that still be the same angle, even though it's a different size? Okay, I'll make it a little bit smaller. Can you see that I can say that this angle is congruent to this angle? And I'm telling you that all of these are congruent. So they're not, I'd say they're not congruent, but they're similar. You've proved similarity, but that's not necessary. That's why you're not one of these for proving congruency is not angle. However, if I give you angle, even though one is a reduced version of the other one or a lot bigger version, to us, it's not I think it's probably the hardest. We prove it later, but see this side's not included. It's side, angle, side. Isn't that weird? We actually like jump. We got side, angle, side. So, and then we have one more. So let me clear this up and go through it. Okay. So let me go to the next. And this one is RHS. Okay. And so what R is for right angle, and that's what the little square is. And that's me right there. Right? So all you need is, so if I say side, if you got one of them right angle, right here, that's a right angle. And that's a 2 tick mark, and that's a 1 tick mark. So we can see that the criterion then for the third side. The other two angles are bound to be equal. So, but because if this side is congruent to that, actually let me do it more like this. So you can see it better, I think. I make it the same. Oops. I make it the same size. There it is. A little bit delayed. Okay. So I'm going to go like this. And I'll make that right angle. And then I'll make it like this. Now, they'll confuse you by spinning it. Called rotation. And then reflection. Okay. And I'm calling this. Okay. Now, I'm saying if they're a right triangle, then we have another rule that we can show that if this one is congruent to this one, you see it? And that this is congruent to this, well, we know this is 90 on both of them. We know this side is the same as that side, and this side is the same side, so this necessarily must be congruent. This is the R right triangle side. So now we have a situation where you have side angle. But that's only for right triangles. Is it okay? Maybe we could do a quick review. And so the way the question will be framed to you when you take the test, it's exactly like this, but it's going to be spun a little bit. So you can see that the two hash marks correspond with that. Okay. They'll not, like, suppose I could peel that off, right? I'd have to turn it like this, and then I'd have to reflect it over like this and lay it on the other one. That's how they try to trick you. They're trying to show that if you can visualize rotation of geometry in the mind. Some people are really good at it. They can actually see two shapes and how they intersect together. I'm not bad, but there's some people that are. So they can see things even got a good idea of their shadow, and then they can work in different dimensions. They can visualize. I don't know. I mean, it's like if you take a cube in 3D, this is a cube. Actually, it's just two squares on the rectangle. Whatever, it's not actually a rectangle, it's called a prism, like a prism. Huh? Yeah, the right triangle prism. Okay, so then you have it like that, right? So what does that look like if I unfold it? It looks like this. So I'll have like this, right? I can lift that one up and back. You see? You can unfold it, you can fold it back up, right? I just unfold and unfold and unfold. You see it? That's kind of interesting because a cube unfolds in 2 dimensions across. And it turns out that a four-dimensional cross. I don't even know if I can do it. No, this is an unfolded 4-dimension in 3 dimensions. You see what happens? It's flattened out. So now, how do I do the fourth? It looks like I think I don't know if I showed you the dolly cross. I'm not sure I can draw it because it's like this. Bear with me here. It goes like this, and then this comes out like this, and then that's another. right? And then there's a cube in the middle, and there's a cube on the side, right? And then there's a cube here. Right? Then, and then I have another one here. That's what oh, and then I have this one comes out. I don't know if this one comes out in front. You see it? And there's another one in the back. I don't know, that is a four-dimensional cross unfolded in our dimension. Huh? I can hear you. Oh, thank you. No, it's a little, it's tough as you can. But you see how the cube, whatever, let's say it's a cube. I can unfold it like I can make it more like a cube, right? But I can unfold it like this, you see? And you see a lot of test questions, they want to check your geometric ability, and they'll have something like this, and they ask you, what does that fold up to be? And so in your mind, you're putting together, and then they give you multiple choice of what possible answers it could be for the unfolding of box. So this Dali, the famous impressionist, actually is surrealist. Did you see his cross before? Let's see if I can show you one. It's pretty cool. Let's see, I gotta get out, right? Okay. Let's see. Now, you have to be careful because he used a lot of body parts in his paintings. And it's kind of, did you ever see the one with the melted clocks?
Yeah.
Hey, senor. Right. Okay. So let's see. Salvador. Oops. Okay. No. Over here. Okay. And let me go like this. His name is Salvador. Super famous. I actually had a student who said he had one. He got it somehow in an auction. Salvador Dali. Okay, I wanted to show you this. This is Salvador Dali. He was, and this is his melted time, melted clock. These are called surrealism. I should have put it across. Look at this one. I don't know. It has the tigers coming out of the fish. See this kind of thing? That's kind of it's called surrealism. But his most famous, well, one of his most famous. You see how he has these like super long-legged things? Look at the United States right there. He has the Uncle Sam hat. So look, do you see these elephants and you see just the impossibility of the legs? You get a lot of that kind of stuff from me. All right, let me see if I can go over here again. An X. Oh, that's all right. I can delete. Okay, I want to do Salvador Dali again. No, I don't want that. I want Salvador. Salvador. What do I have so far? Sal. I need the Dali, but I gotta include this. I want to show you his cross. Here, that one. That's Salvador Dali's cross. Yes, there it is. Can you see what he did? This is his. That's the four-dimensional cube that I'm trying to draw. You see there's a cube in the back? And so this is a tremendous painting because it's so heavy, but yet it's floating. Down here there's more, but the naked woman. And that's it. I just wanted to show you that square. Everybody okay with the angle side angle business? If you need to do that course code, let me know because I gotta enter your grade into the classroom. And then it goes over to